Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2. We would like to present our group discussion mathematics, Chapter 3, numerical method. So before we start, I would like to introduce our members. My name is Salimah Hamzah bin Ahmadullah. My matric number MS192317616622. And our second member is Haris, and our third member is Hani. So Haris and Hani, would you like to introduce yourself?
Okay, my name is Haris bin Zamaluddin and I'm from class 226. My matric number is MS1923178927.
Hi, I'm Hani Masra Roslan. I'm a third member of this group. So my matric number is MS1923272871. So proceed to you.
Alright, thank you to our members. Okay, so before we start, for our chapter 3, numerical methods, we have three subtopics, which are 3.1, solution of nonlinear equations, 3.2, unitary method, and 3.3, trapezoidal rule.
So our first subtopic is 3.1 is solutions of nonlinear equations, such as these equations that shows in the presentations. There is no exact formulas to solve them, so we will use the common method with two main parts. So first, by finding an initial approximate value x, and second method we use by improving this value by an interactive process. So conclusion for solution of nonlinear equation is we can conclude that there is a two main part is first is graphical method and the second one is the algebraic method. So for graphical method, we know that first we need to plot or sketch the graph y equals to fx. The real roots are the point where the graph intersect the x-axis, or we can rewrite fx equal to 0 to the new form fx equals to dx. The real roots are the points of the intersect between the two graphs. For algebraic method, we know that the equation fx equals to 0 has at least one root between x equals to a and x equals to b if are the opposite sign. If more than the one root is a pattern between a and b, sketch y equal to fx. So look at the example of the question. By sketching the graph of y equals to x power to 3 and y equals to 3x negative 1 on the same coordinates as this, show that the equation x power to 3 negative 3x plus 1 equals to 0 has a 3 real roots. So solution is we use the graphical method by the graph y equals to x power of 3 and y equals to 3x negative 1 intersect at the 3 points. Therefore, the equation x power of 3 negative 3x plus 1 equals to 0 has a 3 real roots by sketching the graph. For the next question, show that the one of the real roots of the equations x power of 3 negative 3x plus 1 equal to 0 lies between 1 and 2. For this question, we will use algebraic method. We just substitute 1 and 2 into the equation. So after substitute the value, we get the first equation, we get the negative 1, and the second substitution, we get a positive sign. So
now, we would like to proceed our second subtopic, 3.2, unitary method. So our objective for this subtopic is first, find the root by the unitary method, and the second one, we will be able to solve problem of unitary method equation by using calculator. Initial approximate value is an approximation to a root of equation function equal to 0. Then a better approximation of x1 is given by x1 equal to the initial approximate value minus function of x divided by the derivative of function. So this is the mean of the formula and given by using the unitary method. Find the root of the equation exponent the power of x equal to 4 minus x corrects to 4 decimal places, given that initial approximate value equal to 1.2 as the approximation. So from this equation, we arrange exponent the power of x equal to 4 minus x like this. So we have function of x equal to exponent the power of x minus 4 plus x, and from our equation fx, we have to differentiate, so we get derivative of x at fx equal to exponent the power of x plus 1. We substitute the value of fx, so exponent the power of xn minus 4 plus xn divided by the we substitute the equation
I
of
will show
derivative of fx.
how to use calculator to make it to get answer more easier and faster. Alright, first, alright, we just pull the alpha button and we click here x and then minus. Alright, we use fraction here and then we don't click the equal button, just follow this. Okay, click the calculation and then we just substitute the value of x. Right, so we got 1.060796.
The rule is another rule of integration. Under this rule, the area under a curve is evaluated by dividing the total area into little trapezoid rather than rectangle. In this subtopic, our objective is use trapezoidal rule to approximate definite integral. And secondly is we will be able to solve problem of trapezoidal rule question by using calculator. As we can see in our presentation, the question is 4u square plus 6u, and given n equal to 4. First of all, we must find the value of h. The formula for find value of h is b minus a divided by n. So n is given, so we just put into our formula is 3 minus 2 divided by 4 equal to 1 over 4. You can see in that presentation, our formula is h divided by 2 fx plus 2fx1 plus 2fx2 plus 2fx3 plus 2fx4. Okay, we must remember to put x0 to our x equal to n. Let's say n equal to 4, so the n's should be x equal to 4.
Okay, hello guys. Today I want to explain how to solve trapezoidal rule by using calculator. Okay, the question is limit 0 to -2, 1 over 1 plus e power of x dx, and we give the given n is equal to 8. So first of all, we must calculate the h. So the formula of h is b minus a over n. So we use calculator. So 0 minus 2 over 8. So we got 1 over 4. Okay, we press mode button and pick number 7. Okay, we write the question back. We press equal. Then we start with -2, as we see at the limitation is -2. So end with 0. So step is our value of h. Okay, number h 0.25. So as we see, we can see all the table. So this table we must do by hand. Okay, first off you must do like this. After then you find that all the value, then you plus the value, all the value. We switch to the mode normal. Then we write the question back. We write the formula is h over 2, and we sub the value of 1.381 in here and 5041 in here. Then we got the approximate.
Alright, so what do you guys think the most suitable and effective methods to solve this application of daily life by using numerical methods? In my opinion, I think using interaction methods might help us to solve this application in daily life.
Yeah, some goes with me, Ayu. I think this method are easy to find it, and we have a better approximate value by using this method. And also we can use only calculator to find the solution. So solution and the answer can find it easily.
Well, I'm agree with both of you. Actually, I think that more suitable for this subject is solutions of non-linear equations, because solution of non-linear equations is actually applied to our life without we realize it.
Honey, can you elaborate your explanation about non-linear equation? I would like to hear about it, because I'm not really understand about what you're talking about.
So Hani, you have different opinion from us. Will you explain about it?
So, look at the screen. The process in which chemicals interact to form new chemicals with different composition is called chemical reactions. This process is the result of chemical properties of the element or compound causing changes in compositions. These chemical changes are chemists' main purpose. It is important to mention a remark from Fundamentals of Chemical Reaction Engineering, where the two questions that must be answered for a chemically reacting system are what changes are expected to occur and how fast will they occur, by using multiplicative calculus. This is an indication that mathematical representations are very important for chemical investigations. Consequently, a chemical reaction is mainly represented by a chemical equation which represents the change from reactant to product. The process generally involves non-linear function or equation, so it is compulsory to use and apply numerical approaches. Exemplarily, suppose that a chemical reaction is made and the concentration of the particle ion at the time is given by a non-linear function, fx equals to x power of 3 plus x negative of 4. If we are interested in when this concentration will be 1/2 of its value at the initial time equals to 1.3 seconds and final time is 1.4 seconds, we are need to solve this problem numerically. If as an initial assumption f 1.3 equals to 0 and final assumption is f 1.4 equals to 0, this will be x power of 3 plus x negative of 4 equals to 0. So, by using solution nonlinear equation, we can know that there is a root or not between initial x equals to 1.3 and final x equals to 1.4 if the sign of the two equations is opposite sign. For example, we just substitute 1.3 and 1.4 into the equation. Since 1.3 and 1.4 are opposite signs, thus there is a root between 1.3 and 1.4. Usually, chemists tend to use ordinary numerical method to estimate the root of above equations. However, by using solution nonlinear equation method, whose effectiveness was proved in problems that involve functions like cubic functions, should not be disregarded in many applications. The superiority of the solution nonlinear equation methods can easily observed from this problem. Thank you.